In question 6, the diagram shows triangle ABC where AB is 5, AC 4, and BC equals to 3. Three circles with centers at A, B, and C have radius 3, 2, and 1. The circles touch each other at points EFG lying on AB, AC, and BC. We have to find the area of the shaded region EFG. Now, to find the area of the shaded region, first we'll have to find the area of this triangle and then subtract it from the area of these three sectors. Now, if we have a triangle with the lengths 5, 4, and 3, we know that it will be a right angle triangle, as if you apply the Pythagoras theorem over here. So 5 squared will be equals to 4 squared plus 3 squared. So we can find each of these angles using the using sine, cos, or tan, or we can even use cosine rule to find these angles. So let's say if you have to find the angle CAB, so the length of BC is 3. Applying the cosine rule, which is c squared is equals to a squared plus b squared minus 2 into a into b cos of c. So c is basically 3 squared. So this will be 3 squared is equals to 5 squared plus 4 squared minus 2 into 5 into 4 cos of c. Rearranging the expression, we'll get 2 into 5, 10 times 4 is 40. Cos of c is equals to 25 plus 16 minus 9. So cos of c will be equals to 41 minus 9, which is 32 upon 40. And taking cos inverse and making sure the calculator is in radian mode, taking cos inverse of 32 divided by 40, so that will be equals to 0.6435 radians. So we can use the cosine rule, and even if we had used this the trigonometric ratios to find this, so that this angle, the opposite length is 3 and the hypotenuse is 5, as this angle will be a right angle, as the hypotenuse has to be 5. So if we used opposite over hypotenuse, sine theta is equals to 3 upon 5. So taking sine inverse, so if we take sine inverse of 3 divided by 5, that will still be 0.6435. Now, once we have this as 0.6435, we know that this angle will be, so we know that this angle will be 0.6435. This angle is pi upon 2. So this angle will be pi upon 2 minus 0.6435. So first we can write that the angle ABC will be equals to pi upon 2, as both of these angles will add up to pi upon 2. So that this will become pi upon 2 minus 0.6435 radians. So first finding pi upon 2, so pi divided by 2 is 1.57, and then subtracting 0.6435, this angle will become 0.9357 radians. So this will be 0.9357 radians. Now, once we have the three angles of each of these sectors, we can apply the area of the sector formula, which is area of sector is given by the formula half r squared theta. Now, finding the area of each of these three sectors. So first finding the area of AEF. So area of sector AEF will be equals to half into r squared. So in this case, the radius is 3. So this will become 3 squared multiplied by the angle. So this angle was 0.6435. Then the area of the sector. So this sector is CFG. So this will become area of CFG will be equals to 1 upon 2 into the radius, which is 1, whole squared multiplied by the angle. So in this case, the angle is pi upon 2. And then the area of the third sector will be area of, so that is BEG. So the area of sector BEG will be half into the radius, which is 2. So that will become, so the radius is 2. So that will be 2 squared, and the angle is 0.9357 radians. Once we have these areas, now we can substitute these in the calculator. So the area of the first angle will be 9 multiplied by 0.6435, dividing it by 2. So that answer will be 2.89575 centimeters squared. For the area of CFG, that will be pi divided by 4. So this will be shift pi, will apply pi in the calculator and dividing it by 4. This area will be 0.7853 centimeters squared. And this will be 0.9357 multiplied by 4. And then dividing this by 2, we'll get 1.8714. So the sum of the areas of sectors will be We'll add all of these three areas. So 1.8714, so 8714 plus 0.7853 plus 2.89575, that is equals to 5.55. So this will be equals to 5.55 centimeters squared, and subtracting it now from the area of the triangle. So the area of the triangle will be equals to half base into height. We know that as it is a right angle triangle, so the base is 4 and the height will be 3, or the other way around. So that will become half into 4 into 3. So this will be equals to 6. So the area of shaded region will be 6 minus 5.55 centimeters squared. So the final answer will be 6 minus 0.55, which is equals to 0.45 centimeters squared. Now in the mark scheme, if you look, the answer for the area of the shaded region is given as 0.464, as we have to give our answer to three significant figures. So if I subtract 6 from 5.55, this will become 0.450. Now this change of answer can happen because of some rounding off that has been previously done. So it is better to not round off the answers, and we should only round off the final answer and then give our answer to three significant figures. So this is the actual answer for the area of the shaded region. And if we give this answer as over here, so this will result in a loss of mark. So 1 mark will be deducted for the accuracy mark. So we'll have to make sure we do not round off the answers until the final part.